So we already talked about three methods for computing binomial probabilities, and the fourth method, is to use a table of probabilities. So we've got table A1 in Appendix A of our textbook. Note that it can't be used if n is greater than 8 or if the probability is not one of the 13 values included in the table. So that's a downside to that. To use the table, we're going to look for the right row, we're going to look for the right column, and the isolated number in the right row and the right column represents the desired probability. The row is associated with a particular number of trials n and a particular number of successes in those n trials x. And the column is associated with the desired probability of success in one trial p. So we're going to revisit example 1. Now, in example 1, we were looking at multiple choice questions. Each of those questions had 5 possible answers, A, B, C, D, and E. Only one of those is correct. And we want to assume that we're guessing on 4 of those questions. Now we want to find the probability of getting exactly 2 out of the 4 correct. Now remember, we've already done this. We used the intuitive approach as well as the formula, and we got that the probability of getting exactly 2 successes in 4 trials is 0.1536. I want to show you that you get exactly the same result, or actually a similar result due to rounding, using a table of binomial probabilities. So first we have to identify n, x, p, and q. So we've got 4 questions that we're guessing on. We want to know what the probability is of getting exactly 2 of those correct. So there will be 2 successes in those 4 trials. The probability of getting one correct, or getting a correct answer, in one trial is a 1 in 5 chance because there are 5 answers and there's one of them that's correct. So that's a probability of 0.2. It's a probability of success. Now the probability of failure is, well, 4 out of 5, because 4 out of those 5 options are incorrect. So you have a probability of failure of 0.8. Now now I want to show you how to look up that probability in the table. This is what I was trying to do last time when I accidentally turned off my recording. Okay, so this is our stat textbook. And if we go to table A1, Appendix A, table A1, this lists binomial probabilities. Now in this column, you see the right value of n, and then you see the corresponding x values. So n is 4, that's right here. And then you could have 0 successes out of 4 trials, 1 success, 2 successes, 3 successes, or 4 successes. We want 2 successes out of 4 trials. So we're going to be in this row. And then the corresponding probability that we want was 1 in 5, or 0.2. So we're in this row, and we're in this column. And I don't know if you can see it, but that probability is listed as 0.154. Notice that all of these are rounded to 3 decimal places. So that's what the table says. Now remember, when we use the intuitive approach in the formula, we found that the probability of getting exactly 2 out of 4 correct was 0.1536. If I take this and I round it to 3 decimal places, I get the probability that we saw in the table. So that was our 4th method of computing binomial probabilities, or finding binomial probabilities. And I just wanted to recap all 4 of the methods. Our first method was to use the intuitive approach. So that relies on the multiplication rule and the addition rule. Most people won't use the intuitive approach, but I wanted you to see it at least once so that you know where that formula comes from. Second, we can use the formula for P of X. This is what I tend to do in the homework videos. It's very easy to use, especially if n is small and x is small, and you're only interested in the probability for a particular x value. Now you can also use technology now because you have that binomial distribution function in Excel that you're familiar with. You could actually come up with an entire table of probabilities for a particular number of trials, just like we did in not this video, but in the last video. We want to use technology if n is large. So if you have 100 trials, I really wouldn't do all of that by hand. Well, you could do that. You could do it by hand if you were only talking about one particular x value. But if you're looking for cumulative probabilities, and actually, maybe this should say less than. So if you're looking for the probability that x is, less than or equal to 28, as opposed to finding the probability that x is exactly equal to 28, technology is going to help you. We were looking for a probability that x is greater than or equal to 28, so we were able to quickly come up with a table and then add up all of those probabilities, all 12 of those probabilities, which was very nice. So that's a very appropriate use of technology there. And then worst case scenario, you can use tables of probabilities, but you have some restrictions. You can only use a table if the probability you're looking for is one of the probabilities listed in those columns. You can only use a table if the number of trials that you're looking for is part of your table as well. Now, when you take an exam over this material, you'll have access to this sheet, Triola formulas and tables. It has the formula for the probability of x successes in n trials. So you do not have to memorize that. It's on here. I will also give you a table of probabilities that you can print out and use during the exam as well. Now, you won't be able to use technology, but I'm never going to ask you to do anything involving lots and lots of cumulative, excuse me, I'm never going to ask you to do one problem that requires lots and lots of calculations like this. There's no way I would ask you to do 12 calculations and then add them all together by hand or even with a table. But technology is great when you're looking at real world problems and you're wanting to answer real world questions. And then we want to use technology to our advantage. And I think that's a great idea as long as you understand what the technology is doing. So during the exam, using the formula or a table is very appropriate, and it's going to give you the exact same answer as the technology. So if you want, you could use technology to check all of your answers as you do the homework. So that's how we calculate or compute or find binomial probabilities.